Come on now.
Oh no.
What are you doing? Oh, there we go. Play.
Oh no.
All right.
Welcome back.
Let's do it. Shall we? I'll try to go through them all. We'll see how fast I can do these things. A manufacturer of sprinkler systems designed for fire. Blah, 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 blah. Here's what we need to know. Claim is that average activating temperature is at least 135 degrees. To test this claim, you randomly. Now, is that in the null or alternative? In the null. Why is it in the null? Because it's got an equal to part about it, right?
Yeah.
Mu is at least greater than or equal to 135 degrees. To test this claim, that means alternative is less than. Now, what am I trying to do to this claim? Like, what's my angle at this claim? Am I looking to support or disprove?
Probably disprove.
Why? The claim is in the null. Okay, do you see that? That's how we know I'm trying to disprove the claim. Okay, it says, do you have enough evidence to reject the manufacturer's claim? But the fact that this is stated in this way, a manufacturer of sprinkler systems is at least 135 degrees, right? Okay, so that means I am looking to try to disprove this claim. To test this claim, you randomly select a sample of 32 systems. So n is equal to 32. And find the mean activation temperature, X bar, to be 133. Assume the population standard deviation is 3.3 degrees. Is that S or sigma? Sigma. 3.3, because population. And alpha is 0.01. Or sorry, not 0.01, 0.1. Okay, now, is this going to be a Z test or T test? Z. Why? Sigma is known. So I know I'm going to have a Z score. Is this telling me to use rejection regions or p-values? Doesn't tell me. So you can pick whatever you want to do. I'll use the rejection region. Okay, let's write out our rejection region. Rejection region. And I can do that before calculating our Z score. Now, let me get my yellow piece of paper here. My rejection region. Now, my alpha is 0.1. Okay. My alpha is excuse me, 0.1. So that means I'm looking for negative 1.28, right? Negative 1.28, right? ZC, my critical value is negative 1.2. That's the point. Negative 1.28. Now, do I want to use negative 1.28 or do I want to flop it and do 1.28? What do I want to use?
It's a left tail, so you don't have to do it.
It's a left tail, so I don't have to do anything with it. You know, you don't have to draw this diagram, but here is ZC. So my rejection region is right there, right? Because this is a left tail test. So therefore, I say my rejection region is if Z is less than negative 1.28, I can choose to reject the null. Does that make sense? All righty, let's take a look and see what Z turns out to be.
So for the Z scores, you don't gotta do n minus 1, right? You just do n.
Just n. Just n. The only time you're ever going to calculate n minus 1 in this test, and I'm talking about like this assessment, is when you're looking at the degrees of freedom.
Okay.
Well, I shouldn't say that because there is one that you have to do the standard deviation for. And within the standard deviation formula, you got to do it n minus 1. Okay. All right, so Z is going to be, and again, that's on your formula sheet. Why am I looking? X bar minus mu, 133 minus 135. I know this, I've done this a time or two. Sigma divided by the square root of n, 32. Okay, so 133 minus 135 is negative 2. Divided by, I've got 3.3 divided by the square root of 32. Negative 3.43. Okay. So what is my decision? Is it less than negative 1.28? Yes. So I can say, do I reject or fail to reject? I reject. I reject the null. And then we write out our statement in the end. Okay. So we can say, we can disprove the claim or reject the claim that the temperature, the average temperature, is greater than, is at least 135 degrees at the alpha 0.1 level. And in all honesty, my z-score came out super low, right? So I probably could have gone even a stronger statement, right? This is like 90% confident because I'm using 0.1, right? Even if I had gone to probably like 95 or maybe 98 or maybe even 99% confident, well, what is 0.01? 0.01 is negative 2.33. Yeah, I could have gone way further. I could have gone way stronger. And I could have been 99% confident. But I was only asked to do it at the 0.1 level. Questions about that? Good there? All right, let's take a look at the next one. A sports statistician claims that the mean winning times for the Boston Marathon Women's Open Division champions is at least 2.68 hours. Right there. What's my null?
2.6.
At least again, right? Mu is greater than or equal to 2.68 hours. So therefore, the alternative is mu is less than 2.68 hours. All right, now, where is my claim? In the null. Without reading the rest of the problem, what am I trying to do? Prove or disprove? Support or disprove? Disprove. The mean winning time of a sample of 30, and it's 30. X bar is 2.60. Assume the population standard deviation, sigma, is 0.32. And we're looking at alpha 0.05. So again, so this is like saying we are going to be 95% confident in our answer, right? 95% confident in our choice. Again, it doesn't say to use p-values or rejection region. I like to use rejection region. So let's find the rejection region. Okay, so the rejection region with the alpha 0.05 is going to get me a ZC of 0.05. Negative 2.5, it's kind of in between. We'll go 7.5. Negative 2.575. Honestly, either way you round it, it's probably going to come out to be the same conclusion. Whether it's negative 2.57 or negative 2.58, whatever. Okay, so my rejection region is going to be, therefore, now, is this a left tail or right tail?
Wait, isn't that the left tail? Yeah, or no, isn't that for the 0.01 to 2 point? Isn't 0.05 95%?
What did I do wrong? 0.05.
Or is that right?
I did 0.005.
Yeah.
Ooh. 0.5. 0.05.
1.96. So it is.
1.645. 1.645. Right?
Wow.
Where am I getting this? Yeah. I'm looking at 0.05 in the table. Don't look down here. That's two-tailed.
Oh, that's right. Okay.
Yeah, that's two-tailed. Keep looking in your table. Look for 0.05. Here, let me pull it up. Where is my z-score table? That would have come in chapter 4. Nope. Chapter 5. this it? Table 5?
05.
Nope, that's not. That's the answers to chapter 5. Oh, standard normal table right there. Bingo. Okay, so I'm looking for, what am I looking for? 0.05, right? So I'm going to go 0.05. Where's 0.05? See, my problem, I went to 0.005. So 0.05, right between here and here, right? Negative 1.6, halfway between negative 1.645. Yeah. Even if, again, you had gone to negative 1.64 or negative 1.65, it's probably going to be the same decision in the end. Negative 1.645. That's right. Again, left-tailed, correct? So I can use that z-score. So my rejection region, if z comes out less than negative 1.645. Let's calculate that. Let's calculate that z-score. So z is equal to x bar 2.6 minus mu 2.68 divided by sigma 0.32 divided by the square root of 30. All right, so negative 0.08, right? 2.6 minus 2.68. Wait a second. 2.6 minus 2.68. Yeah, negative 0.08. Why did I overthink that? Divided by 0.32 divided by the square root of 30. Negative 1.37. Okay. Can I reject? No.
No.
Negative 1.37 is not less than negative 1.645. Right? So this is our choice. We fail to reject the claim. Right. And now how do we make that statement in the end? We say there is not that looks like an F. Not enough evidence to reject the claim or disprove the claim or reject the claim that the average time, the average winning time was at least 2.68 hours. There's not enough evidence to reject the claim that the average time was at least 2.68 hours at the 0.05 level. It was a 0.05 level, correct?
Yep.
0.05 level. Maybe if it was at the 0.1 level, we could have rejected it. What was the rejection region? Yeah, negative 1.28. Would I have been able to reject it at the 0.1 level? Yeah. But because I went for a stronger statement, I failed to reject. Questions about that? Let's keep it rolling. A consumer group claims that the mean acceleration time from 0 to 60 for a sedan is 6.3 seconds. A random sample. Now, right there, I can define my null and alternative. Right? What is my null?
X equals 6.3.
Yeah, mu equals 6.3. Okay, am I looking to prove or disprove that claim? Disprove again. A random sample of 33 sedans, okay, n is 33, has a mean, x bar, of 7.2. Assume population standard deviation, sigma, is 2.5 at the alpha 0.05 level. Now, do I even need to recalculate the 0.05 rejection region? I just did it, right? I literally just did it. Copy. Nice. Look at that. Smartboard magic. All right, so now let's calculate our z-score then.
Do you have something for the two-tailed?
Oh.
Is it plus
Do I need to recalculate my rejection?
Yeah.
See, I thought I was being slick.
So this is where you use the
Thought I was being fancy.
This is where you use the box on the bottom.
Nah, we don't even need the box in the bottom. Well, I guess we could.
Well, would it be the same? If we
Hold please. If alpha's 0.05, what number am I really going to be looking for? 0.025. Remember, because we got to take alpha over 2. So 0.05 divided by 2 is going to be 0.025. Okay, so let's look there. Let's look for 0.025.
negative 1.96.
Negative 1.96? Yeah, we see it right there. Negative 1.96. Now, coincidentally enough, do you see it there too? Right? Because I am talking these critical values that we were using for our confidence intervals kind of relate to the two-tailed test. Yeah. All right, so 1.96. Now, again, I've got to think about plus or minus, right? Plus or minus 1.96. Plus or minus 1.96. That means my rejection region is I could be less than negative 1.96, or if z turns out to be greater than 1.96. So I really have two options here, right? Because it could be above or below. It could be both extreme values. Let's figure out what our z-score is. Man, I was trying to be so fancy. I'd have to recalculate. Butchered it. X bar minus mu, not mu minus x bar. X bar 7.2 minus 6.3 minus mu over sigma 2.5 divided by the square root of 33. 7.2 minus 6.3, that's 0.9, divided by 2.5 divided by the square root of 33, 2.07. Okay. Now, it came out positive, so if it comes out positive, I got to go with this side. Is 2.07 greater than 1.96? Yes. We can reject this claim. Okay. So we can reject the claim that the average speed, average speed, average acceleration time is 6.3 seconds. At the 0.05 level. You know, we could kind of say we are 95% confident in this. Yeah, of course.
I think 3 and 4 are like exactly the same. Pretty much. Probably skip 4.
No, they're different. How are 3? Any questions on 3 before I move on? Numero quattro. A used car dealership says that the mean price of a 3-year-old SUV is $20,000. You suspect this claim is incorrect and find that a random sample of 22 similar vehicles has a mean price of $20,640 and a standard deviation of $1,990. Assume that the sample is normally distributed. What makes this difference from the previous problem?
different standard deviation.
It's a different standard deviation. You see the difference? Find that a random sample has a mean and a standard, not a population standard deviation, but a sample standard deviation. And that's a T. Yeah? Okay, so first off though, we are right in that this is going to be a two-tailed, right? So it's going to work that same way. So mean price is $20,000, and that's the claim, right? And we suspect that that's not right. We suspect that's incorrect, so it makes sense that the null, that's why the null has the claim. All right, so we say n is 22, and it's important that we say this because n is 22, right? N is 22, x bar is 20,640, and a sample standard deviation, S, is 1,990. Alpha 0.05 level. Questions about that so far? All right, let's get it going then. Let's find our rejection region now. Okay, so alpha is 0.05, and it's a two-tailed, so alpha over 2 is 0.025. And now we have to talk about our degrees. Actually, you know what? Do I even need to worry about that in my T?
Not yet.
Look at the top of my T table, right? Remember, for a two-tail, it's kind of like already done for you. Two-tail alpha, right? You don't have to split it in half when you're looking at a two-tail T distribution. What is my degrees of freedom, though? 21. So I'm going to go down to 21. Look at the two-tail 0.05. Two-tail 0.05. 2.08. That you guys had?
Yeah.
2.08. So TC is 2.08, which means that my rejection region is going to be T is less than negative 2.08 or T is greater than positive 2.08. If either of those come out to be true, then I know that I can reject it all. Alrighty, let's find our T-score. X bar 20,640 minus mu 20,000 divided by S divided by the square root of n. Now, again, it's the square root of n, not the square root of n minus 1. Now I'm second guessing myself. It is just n, right?
Yeah.
Probably.
Okay, yeah, it is n. 640, 20,640 minus 20,000 is 640. Divided by, I've got 1990 divided by the square root of 22. 1.51. Okay, so is 1.51 greater than 2.08? No. So we fail. Right? We fail to reject the null. So again, we say in our statement, there is not enough information to reject the claim that mean price is 20,000 at the 0.05 level. Maybe if we decreased that, we would be able to reject that claim. But if we want to say that we are 95% confident, then that's not enough. Questions there? All right, 2 more to go. Yeah, we got 20 minutes left. 10 minutes per problem. I don't know, that last one we got to actually calculate S. All right, a State Department of Transportation claims that the mean wait time for various services at its different locations is at most 6 minutes. A random sample of 34 service locations has a mean of 10.3 minutes and a standard deviation of 8 minutes. Ooh, big standard deviation there. Is there enough evidence to reject the claim at the alpha 0.01 level? So now, is this going to be a strong statement in the end if I can reject the null? Yeah, it's going to be like a 99% confident statement, right? So I better have this Now, is this going to be T or Z? T. Yeah. So it's going to be it's going to have to be a pretty big T score. All right. So my null is at most 6, right? Mu is less than or equal to 6. My alternative is mu is greater than 6, right? And their claim goes up here. And we're like, yeah, right. No way. It's less than 6 minutes. No way. All right, so n is 34. X bar is 10.3. S is 8. And alpha is 0.01. Is this a one tail or two tail? One tail. So I'm going to use my rejection region accordingly, right? This is a one tail. What's my degrees of freedom?
33.
So I'm going to go down to 33. Down to my 33 row. One tail, 0.01. Second to last column. Yikes. 2.445?
Yes.
2.445. One tail, 0.01. Yep, 2.445. Now, is that going to be positive or negative? Do I use 2.445 or do I have to make it negative? Negative. Greater than.
Oh, yeah.
Oh, that's not an or equal to. Right? Because think about it this way. I want to end up there, right? So I got to use the positive.
You don't change it.
You don't change it. What's that?
Wait.
I think you might have mixed it up.
Yeah, because isn't the claim a left tail?
You always go with the alternative.
Okay.
Always the alternative, right? Because look here, the alternative was a less than. That's why we use left. The alternative is a greater than. So got to use right.
Points in the direction.
What's that?
The greater than sign points in the direction you need to go.
Exactly. Yeah. And it's always through the alternative, not the null. Through the alternative. All right. So let's take our t-score. T is going to be x bar minus mu over sigma. Oh, sorry, not sigma. S divided by the square root of 34. It's a giant standard deviation. Oops, wrong button there. 10.3 minus 6, so 4.3, divided by 8, divided by the square root of 34. 3.13. Okay. I should have said t is greater than 2.445. Right? That's my true rejection region if t turns out to be greater than 2.445. So 3.13, is that greater than 2.445? Bingo! We can reject this claim because there is no way that the wait time is 6 minutes at a DMV. Okay, so we can say we can reject the claim that wait times are less or are, what did I say? What was the statement? At most. That are at most 6 minutes at the 0.01 level. Another word to say that is we are 99% confident in that decision. Yeah, almost certain. Question about that one? All right, last one. What we got here? A dean of a university estimates that the mean number of classroom hours per week for full-time faculty is 11, which is ridiculous. That's crazy. That's crazy. Like that the professors like in class hours per week is 11. How many hours per week am I in class?
More.
I mean, I've got 5 classes.
Don't they make the big bucks?
Yeah, exactly. Like
Crazy.
about an hour per class, 5 hours. I'm at 5 hours per day.
Dang.
Per day.
You should switch jobs, go work at like Akron or something. Just
You know, I technically could, because now I am like, now the fact I've gotten my master's and have those credentials to teach CCP, like the lady at Jackson who teaches CCP Calc teaches like the night classes for Kent State Stark, and she's like gonna retire soon, so she asked me, like, would you want to take that over?
you want to.
Yeah, because then like my kids can go.
Yeah.
You know.
Oh yeah, they do that.
Yeah. All right. By any means. Sorry, got way off topic. As a member of the student council, you want to test that claim. A random sample of number of classroom hours is shown in the table. Now, what is my angle here? I just say I want to test that claim, but what is my angle? Do I want to disprove or support that claim? Disprove, because university estimates that the mean number of classroom hours is 11. So my null is mu is 11. So therefore, my alternative is that it is not 11. So my claim is going here. So the only way that I'm truly testing this claim is I am going to disprove this claim, right? I'm going to disprove that claim.
Yeah, you are.
That's right. Confident.
Is it
Now-
always going to be disproved on the test too?
Did I say? Are they
It's
all?
disproved
They are all
They're all
disproved.
disproved.
I didn't mean for that to happen. I chose problems out of the book, so they're almost certain not going to end up like that.
Are they all going to be like where you get to choose between like rejection region or like?
Yes. So you can choose to do p-values or rejection region. Okay. It's about the same thing. All right. So x minus x bar. Alpha, we know that n is 1, 2, 3. Oh, it's 11, right? No. 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8 classrooms. Do we know x bar yet? No. Do we know s yet? No. Do we know alpha? Yeah, 0.01. Okay, and we know that this is going to be a t, right? First things first, I got to find my x bar. 11.8 plus 8.6 plus 12.6 plus 7.9 plus 6.4 plus 10.4 plus 13.6 plus 9.1 divided by 8. Did you get your mean to be 10.05?
Yep.
Did you? Did you?
I-
She's just saying.
I
yes.
use 11.
Did you use
I
11?
used 11.
That's pretty far off.
Yeah. So,
10.05.
yeah, your teacher next time.
All right. So now, you know what? I'm gonna. Whatever. X minus x bar squared. The reason why I need x minus x bar squared is because my standard deviation formula, sample standard deviation, is S is equal to sum of our x minus x bar squareds divided by n minus 1. And that's the square root of that, right? So that's why I need my x minus x bar squareds. Okay, so I'm going to take 11.8 minus 10.05 squared. And that's going to get me 3.06. Okay, let's do 8.6. 8.6 minus 10.05 squared. And that's going to get me -1. Oh, squared. 2.10. 2.1. 12.6. You know, I'm just going to go back here. 12.6. 6.5.
4.62.
And I'm going to do 7. 7.9. Oh, shoot, squared. 4.6.
No cheating, dude. trying to give you the answers.
Yeah, it was like 4.62.
Oh, were you really? Oh, thanks, buddy. I appreciate you.
Who's called me bud?
6.4. What's the next one?
Disrespect.
Have you done the next one yet?
No, I'm going in.
Hey, you do 10.4. Do 10.4. I'll do 6.4.
Oh, I did 13.6, but I'll do that.
Squared. 13.32. What's 10.4?
0.12,
0.12. What's 13.6?
12.6.
I'll do 9.1. I won't be late. 9.1 minus 10.05 squared. And that gets me 0.90. All right. So, and now we've got, I'm going to add all these up. 3.06, 2.1, 6.5, 4.62, 13.32, 0.12, 12.6, and 0.9. 43.2 divided by 7. Right? 43.2 divided by 7. And then I'm going to square root that. 2.48. All right. Okay, here we go. Now we can truly test the claim. Our rejection region, it's an equality, so it's a two-tail. Alpha 0.01, degrees of freedom is 7. So T table, alpha 0.01, two-tail. Two-tail 0.01 with a 7. Ooh, 3.499. Ooh, this is going to have to be out there. 3.499. TC is 3.499. So therefore, my rejection region is if T turns out less than negative 3.499 or T is greater than positive 3.499. Let's see what we got, though. T is equal to X bar, 10.05, minus mu, divided by S divided by square root of, now be careful, square root of 8, not 7. So 10.05 minus 11 divided by 2.48. Give me a drum roll. Divided by the square root of 8. Square root, whoa, what the heck is that thing? Square root of 8. Oh, it's way too low. Negative 1.08. So since negative 1.08 is not less than negative 3.499, we have to fail. We cannot reject that claim. Now, can we say that the claim is true? No, we just, it's just not guilty. It's not necessarily innocent, it's just not guilty. All right, so not enough info to reject the claim. That average hours is 11 at the 0.01 level. Yeah. Yikes. Sorry for the poor handwriting.
We made it.
Let's go. That was fun.
Yo, good time, good time. We just got
I was talking with my wife last night, and she was like, "What are you doing in class tomorrow?" Because we were talking